Welcome. My name is Hazlett. I'm a software engineer at Docker, and today we're going to talk about Containerd, universal building block for containers. So before we get started, quick poll: who's heard of Containerd? Okay, a couple. What about containers? Everybody probably heard of containers, right? Docker. Okay. So today what we're going to talk about is a project called Containerd, which we spawned out to be a component for a container runtime. Quick background about myself. I've been at Docker a little over 3 years, worked on everything from the open source side, from machine to the engine, implementing the secrets, to the enterprise with the early version of UCP, to Containerd doing the event subsystem, and now I'm working on layer 7 load balancing with SwarmKit, our clustering, and our enterprise product. So we'll just jump right in. What is Containerd? So Containerd is an executor and supervisor for containers. So if you know about containers or look into Docker, Containerd provides an abstraction above the operating system. So it would be much easier for a platform to have an abstracted call such as mount instead of dealing with syscalls like in the Linux or Windows kernel. So what Containerd does is provide an abstraction on top of the operating system. It is a project that we spun out. We actually have had Containerd since I think Docker version 1.11, but for various vendor reasons and community reasons, people didn't want to necessarily use Docker to build on top of the platform, so we decided to spin this out into its own project. And it actually is a CNCF project, which is the Cloud Native Computing Foundation, along with other things like Prometheus, Kubernetes, and these. It's used by container platforms. That's the intended use as a building block. So it's used by so Docker. We use it internally. Kubernetes uses it through the CRI Containerd plugin. There's lots of others that are out there, including another project, Linux Kits. Lots of things use them. It's aimed to be a building block. So the goals of the project, very, very tight. The Containerd team does not want it to sprawl out and kind of turn into its own platform. So therefore, if you look actually in the repository and the goals of the project, it's meant to be a gRPC-based API client and library. So the backend server is all gRPC-based. It's very high performant. It is OCI runtime and image spec compatible, 100%. Quick sidebar, OCI is the Open Containers Initiative, which we spun out to have a non-vendor specific, like not controlled by Docker, way to define specifications for runtime and images. Containerd is 100% OCI compliant. And the goal is to have lightweight decoupled systems. So since it's aimed to be a building block, if you want to use the runtime component or the image component or one or the other, not those, all of the systems are decoupled. So you can turn them on or enable them or even add your own if you want. So it is in Containerd. Containerd does not have a UI. Today I do a lot of live demos, so today we're going to be doing using a tool called CTR, which is the Containerd CLI, command line interface. It is intended to be like a debug and development tool. It's not meant to be used for production grade. So Containerd, as I said, is meant to be a building block by other platforms. It doesn't do image building, so if you're familiar with Docker images or container images, it doesn't do the build. It will do push-pull through image distribution, but it doesn't do the build. It doesn't do logging, volumes, or networks. So the logging is a little different. It does provide the plumbing to use a logging system, but it doesn't have a command such as like CTR logs. Same thing with volumes, networks. We'll dive into this a little bit once we get in. And clustering. It's meant to be a component for the runtime and not do any clustering such as like SwarmKit or Kubernetes. So quick sidebar, we get a lot of questions about, okay, well, Containerd it's a runtime for containers by Docker, then what is Docker? Docker started out, I would be the first to admit we are terrible at names and terrible at marketing. We have Docker, which used to be a runtime, which turned into a platform, which we then spun out into a project called Moby, which is the open source version, and now we have like Docker Enterprise and Community. It's a mess. But basically, Docker right now is a platform, right? So it does everything that I just said Containerd isn't supposed to do. It contains a UI around that might be the stacks or compose files, to the enterprise product, to our developer CLI, It has a volume concept which you can use plugins to do all kinds of different things like Gluster or S3 for the backend plugins. Same with logging. So you can have Docker service logs or Docker logs and get all of your centralized logging as well as with plugins to do so like FluentD or Splunk. Clustering built in, so with SwarmKit, you can do clustering across hosts, secrets, configs, all of these things. That's what the Docker platform is. Containerd, however, is the component that Docker uses to interface with the operating system to actually execute and run containers on both Windows and Linux. So we're going to jump right in. If you're familiar with Docker, you're going to know a lot of this is going to look familiar, but I'm going to go into it. It's not going to be a super deep dive, but it's going to be a deep dive or a dive into how Containerd handles these images. And Containerd is used, like I said, in lots of different things. It's used across lots of cloud platforms and lots of container platforms. So first, if you want to run a container, you need an image. In Containerd, these images are comprised of a digest, and the digest has a list of manifests. If this is kind of going over, don't worry about it. If you have questions, you can ping me later. And also, please feel free. It's very informal, so interrupt if you have questions. But the list of manifests is basically just, it contains metadata and references to use file system layers. So the manifests are platform specific. So you have one that says, this is the Linux ARM or Linux AMD64, and this is the ARM V8 or whatever. Those have metadata about which references to use, which layers of the file system, which are the actual binaries and bits that it will pull down and use. Images in Containerd are content addressable, and they have the full OCI image spec support. We also, Containerd also supports remotes. So in the old days, where if we wanted to have a platform built on top of Docker, you, by default, and it is implicitly specified that it would pull from the Docker Hub, which is our public open or public available registry for images. With Containerd, we kind of went rounds and rounds with some vendors in the community, one specific Red Hat, to where they had a valid point. We don't want to have to just say if you pull Alpine that it pulls from the Docker one, right? We want to be able to specify it. So in Containerd, we support remotes, but you have to give it the full address. So in this case, it's docker.io, library, Alpine, whatever. This can be anything. So this could be the GCR. This could be an image from AWS. It doesn't matter. Or a registry from AWS. So, as I said, I like to do live demos, so let's go ahead and do this. Hopefully, let me zoom this in. Everybody see that, hopefully? Yes? All right. So the tool we're going to be using is CTR. This, if you're familiar with Docker, this looks similar, but there's not nearly as many commands. This is aimed, as I said, to be lower level. So this can do things like you can view plugin system, or the plugins actually built into Containerd, containers, events, images, namespaces, all this stuff. We'll get into that. So we want to do we want to look at images. We can do CTR images list. We have none. So what we want to do is we want to pull from a remote registry. CTR images pull. We'll do Redis. So we do a pull. It's going to go, and we're done. It went out and resolved that to the content addressable store, grabbed the index, found the manifests, found out what layers it need to grab, and pulled it down. So, great, we have an image. What do we do? Well, we can look at it. We can see the ref, which is just the reference that you have in the system that references that image. I know it's kind of hard to read on the screen. I apologize. But you can do things like you can look at the available digest that it has or the platforms. So in this case, the Redis Alpine image supports Linux 386, AMD64, ARM, and S390, as well as add your own labels and metadata if you want to your images. So great. This isn't very interesting yet, so let's continue on. Containers. We're going to kind of jump ahead of a few underlying things, but for now we'll jump to containers. As I said, Containerd has full OCI runtime spec support. So what does that mean? That means when you run a container, what it will do is it's actually going to, the spec contains the configuration, execution, and the lifecycle of a container, which are things like mounts, user IDs, namespace support, whatever you need inside of that. That is in the spec for the runtime. Containerd will take that and then execute that. It supports any OCI compatible runtime. By default, we use runC, which is our tried and tested, hardened, we've used it for years, executor in Docker. But you can use any OCI compatible runtime. And in fact, you can pick the runtime you want at runtime. So when we run this, if we do a container run, We're going to do CTR run, very similar to like a Docker run. We don't have near, if we just check the options for a second, we don't have near the options or the arguments that Docker supports, and this is because it's meant to be a building block. All those other things like external volumes, plugins, networks, those, that's outside, intended to be in the platform. So here we're going to do a couple. We're going to do a run. We're going to clean up after ourselves. We're just going to say remove, specify the image reference, and then give it a name or an ID. So if we run this, we can see that it starts the Redis, right? This looks like every other demo that you've seen. However, there's a few differences. Here you can actually, if we look at CTR run, you notice that you can specify runtime. This can actually be specified when you run. You can have any runtime you want, as well as any other options. I want to put a few, explain a few things first. So, as I said before, Containerd doesn't do networks, right? So if we run something, what does that actually do? Well, let's take a look. So I'm going to pull another image. Just going to pull Alpine. And then we'll actually run a container and see what we have. So if we do a run, I'm going to allocate a TTY, clean up after myself. Give it a name, and then the command we're going to run. So I'm inside of a container. If I look at the network interfaces, I only have the loopback. Right? So by default, Containerd gives you nothing that you know of as far as like software-defined networking today. So in Docker, if you do a -run, you'll get a virtual Ethernet device. It'll give you all this NAT plumbing, access to the internet, and all these good things. Containerd, in the clustering world, so like Kubernetes, OpenShift, which uses Kubernetes, Docker Swarm, the software-defined networking is a critical component. So Containerd does not want to be opinionated in that front because, for example, in Docker, we use the CNN model. Kubernetes uses the CNI model. So we don't want to say, this is how you have to do networking. So by default, you get nothing. You have to bring your own. Now, there is an option that you can do if you want to be able to access the internet. We do allow you to use the host namespace. You can do net-host, and this will give you all of the host interfaces. So you can get to the outside world, but this is it. It's either nothing or you get the host. If you want to bring your own, you have to implement your own system, which is what Docker does and what Kubernetes does with CNI on top of the CRI Containerd. So great, we've ran a container. This is what we've seen before. So let's get into the good stuff. So snapshots. In the early days of Docker, we had what we called graph drivers. If you've ever used Docker deep on non-Ubuntu platforms, you'll notice that the graph drivers can sometimes give you trouble, depending on what you use for the underlying storage. By default, on Ubuntu, it was AUFS. We've now moved to overlay AFS 2. However, on such platforms like Red Hat, you would use Device Mapper. The graph driver quickly outgrew its interfaces when things like Device Mapper started coming along. So what we did for Containerd is we took a step back and said, all right, what exactly does the storage have to look like? So we redesigned it. I give credit completely to Michael Crosby and Stephen Day, fantastic engineers that did this, and they came up with this snapshot interface. It's a very clean interface to do file systems. And what it does, it actually enables you to kind of do anything you need in your plugin. By default, built-ins, I believe, are a naive snapshotter, which is just kind of local, and then Btrfs and overlay. But there are also community drivers or snapshotters for like AUFS, overlay, and I believe Device Mapper. So they're not in the core, which allows us to have a smaller code base to manage, less bugs to chase, and keeps it stable, and it's easier to maintain for the snapshotter implementers on the plugin side. So let's take a look at these. A snapshot represents a file system state. So this can either be an active, which is like read-write, which we'll see that is actually like a container that's running, or a committed, which is read-only, such as if you do a commit or when you pull a layer. So if we take a look at these, we can do the snapshot command and do a list. If we do snapshot ls, we can see it's hard to read up here, I apologize. But the top one, which is Redis, which is our container that is running in the other buffer, it's set as active. which means it has read-write. It can be actively written to. The rest are committed. So these are read-only. These are the layers that are the parents, the various layers through that image. And if we look at this, we can do snapshot tree. We can see, we can actually see the hierarchy of these layers in there. So Containerd gives you all of this, it's a great hierarchical method to layer these on top, and you can actually see everything that's in there, all content addressed. The CTR command that I'm using just touches the surface. The API underneath is really, really powerful. It's very simple to use. We'll see that towards the end. But you have a lot more control around the actual root.fs and a lot of different snapshot technologies using the API. Sure.
So is the point of that to be able to roll back
Oh, so the question is the snapshot intended to be able to roll back? You can build that in. Containerd doesn't have that like in the CTR tooling, but you could do that to where you swap back, and you can do things like, you could create things off of that SHA. So you could use these specifically for you could commit it and then use it from there, and then spawn any containers from that snapshot that you want.
I'm just wondering what the motivation would be for this capability other than that.
Yeah, I think the question was just wondering the capabilities and the intention for the snapshot. It's kind of misleading, the term snapshot. It's not the exact same as what you would think as like a disk snapshot. It's more of, it's similar, but it's not what you would traditionally do of like a restore, checkpoint restore thing. You can absolutely do that. Each layer is its own independent, so you could create an image from that, or you could restore from that. Right, and spawn a container from that. So yeah, you could do that. You'd have to worry about external data. So the difference would be is this snapshot doesn't have, if you do like a bind mount or use another volume, so it doesn't do that data. You could write a plugin, I suppose, that would do it, or a snapshotter that would take that in. But if you use something like external volume, so that's where you get into a little.
Is it trying to be efficient in terms of diffs between states?
Yeah, absolutely. So we'll see that in just a second. But what it does is if two images have the same layer, and you say pull from here, if it already has it, it leverages that. So as you do, as it lays the layers of the layered file system, it will just use the existing snapshots that it has. Good questions. All right, namespaces. So this is probably this is one of my favorite features of Containerd. We have been asked for namespace support in Docker for literal years. We don't have it, partly because, as I said, it's a platform, so there's lots of various pieces, volumes, secrets, configs, etc. But what you have to do if you want to implement namespace support is at the actual executor level. So it's no good to me if I have namespace support for, say, configs, if everybody can see all the containers, right? So Containerd has this built-in by default. So the multi-tenancy, what it does is it provides separate collections for the metadata and runtime objects, such as like the snapshotter, images, containers, and those. The data is isolated unless it's allowed to be accessed by the service. Now this service is an overloaded term. It's not service user service. This is a Containerd built-in service. So in Containerd, the architecture, as I said, a lot of loose decoupled systems, that's what those are. So things like the snapshotter service, container service, the image distribution service, all of those, if they allow data to be shared, such as when you do images and poll, then they can be shared across namespaces. But if they're not, like containers, then they can't see each other. And this makes really interesting use cases. For example, you could have a single Containerd runtime on your host and leverage both or all of Docker, SwarmKit, Kubernetes, your own platform, anything you want by leveraging these namespaces. And it's still incredibly efficient because they all will leverage the same layers since they're content addressed, but you'll have the complete isolation between containers. And so we'll take a look at that to see what that actually does. So if we do a CTR namespaces ls, we'll see by default there's a namespace called default. If you don't specify anything, everything goes into there. So if we do images, we have 2 images, we have containers. They're all in that default namespace. So let's create one. We can do namespace create, and we'll just call it def. So if we do a list on this, we now have 2. Great, what do we do with it? How do we use it? So there's 2 ways. If you use the API, there is a function called with namespace. We'll see that later on. To use it from the CLI, we just use an environment variable. So we'll specify containerd namespace equals dev, and now we can do any of the commands that we have. So we do containers ls. Oh, come on, Wi-Fi. There's no images, or there's no containers, and we can even do the same thing with images. There's no images, no snapshots, nothing. This is a complete separate namespace for it. So we can actually do, we can run containers in it. So now let's pull an image. We'll pull the same Redis Alpine. You notice it went very, very fast. It's leveraging the other layers in the file system that it already has. And then the actual operations, we're just checking to make sure that all of those matched the hashes. So now let's do a run. We'll do --rm so we can clean up after ourselves, docker.io, library, Redis Alpine, and we'll name it Redis. We see it's running again. Great, that's what you expect. However, if you notice, the IDs are the same. Any container platform that you use today, Docker, Kubernetes, they have to have unique IDs, right, in the namespace. So if you were, I'll just use for Docker, for example, if you wanted to run a container named Redis, you can't. You'd have to do like redis-dev or something like that, and then everything's together. With container namespaces, we now start splitting those out. So if we look at, as I said, in the namespace of dev, there's only one image. So all of these are separate, but yet I can use the same IDs. So you could have something like a stack or like a compose file or a Kubernetes YAML that you deploy that is the same IDs and has the exact same naming structure, but deploy them to multiple namespaces using containerd that they all split out. So now they're all isolated, but you don't have to finagle with like hacky names and IDs. So those are namespaces. Incredibly powerful for the building block. Any questions so far? Cool. All right. My other favorite are the events. And not because I worked on them. Stephen Day did the original design, and I just helped him. But the events, I've been interested in event-driven stuff around containers since the very early Docker days when we first added Docker events. Events allow you to do very, very powerful reactive things when you're running in the platform. So in containerd, you receive notifications for all of the containerd operations. So things like images, snapshots, commits, containers, image pulls, all of these things are there. And it uses a pub subsystem, publish subscribe, for the containerd services. So for example, if you have, if you wanted to implement your own service, you can create that. You then just compile the containerd run binary. It's very easy. And then you could publish an event by just doing a publish to the event service. And then whatever subscribers you have, it's the pub sub method. But allows a very powerful system so you can have it built into your service with extremely minimal code. So let's look at events. So if you're familiar with Docker events, or I believe Kubernetes has the same concept, we just run CTR events. This is going to open up a stream connection back via gRPC and listen for events and then just print them to screen as we do things. So let's kill this container real quick, and we'll go down a little bit. We'll run it again. So we can see, I know it's terrible on the screen, I apologize, but it's time-stamped, and then it just gives you the namespace that actually is executing, so you can capture events. By default, the CTR command will go for all namespaces, but the event service supports a rich filter mechanism, so you could actually filter upon anything you want. You could filter upon event type, namespace, anything you want. But here we can see it's actually preparing a snapshot. This actually, the cool thing I like about events is it gives you a really good picture of what is happening when you do an operation in containerd. So for example, if you're, what exactly happens when I do a container run? Well, this is what it does. It prepares a snapshot. It then creates a container, which is like the metadata object. It then creates a task. In containerd, a task is the equivalent to a process that's running. It then, I know this is kind of jumbled, it gives you lots of rich information about the task, and then does a task start. So you can see very, very clear exactly what is happening. If you then, let me go down a few lines. If you then stop it, you can see that it does it detects that the task exited, right? And it gives you the PID as well as the exit status. It then does a task delete, so deletes that task from the containerd service. and removes the snapshot because I told it to clean up after itself. It's --rm. If I didn't do --rm, there wouldn't be a snapshot removed there. It would actually keep it. And then a containers delete, which deletes the container metadata inside of containerd. So the event service is very, very rich. A little sidebar, what you can do with it, the types of things. As I said, containerd doesn't have networking support, right? As you would expect from software-defined networking. A project I did on the side, I'm very, very interested in CNI. I absolutely love the Container Networking Initiative. I think it's a fantastic model. I wanted to be able to use CNI with containerd. So I wrote a very small program that actually attached to the containerd event service. And anytime it detected this container create, it would get this container ID, and then you leverage a CNI network to do an actual attach to that network. So then when you did a containerd run, you would have the software-defined overlay network that you'd expect, or whatever plugin you wanted to use in CNI. When it exited, it detected this containers delete one, used the ID to then detach it from there. So the events give you very powerful to do this, and I don't know exactly how we do it inside of Docker. I don't think it's, some things are event-driven, some things aren't. But this is how you could build, gives you a lot of great power for a platform if you want to integrate with it. So those are the event stream. One more service I want to talk about. I know I'm kind of going quickly, a lot of information, but the metric service. In any container platform, observability and visibility is absolutely critical, right? I mean, if you can't have information about what's running, you're flying blind without a net. So what containerd does is it provides metrics out of the box from the C groups and the container information, and exposes it as an endpoint, right? An HTTP endpoint. This gives you container data such as CPU, memory, lots of memory information, PID, as well as the gRPC data, things around the actual API that's executing. And it's Prometheus compatible, which is also a CNCF project. So if you use Prometheus, if you don't use Prometheus, I highly recommend check it out. It's awesome. And if you do, you can attach this. You just specify the endpoint in Prometheus as a target. It'll scrape it, then you get a lot of data. One caveat here to mention, it is not enabled by default because, as with any observability in any system, once you add that, it adds overhead and cost. It is minimal in containerd because it's all local. It's local in memory, so you don't have to worry about like traversing networks or trying to crawl and scrape metrics across the network. It's all local on the machine, but it is extra. So it's not enabled by default. To enable it, I won't go into it here on how to actually configure containerd, but it uses a config file. You just specify an address, TCP address. So you give it an IP and a port to listen on, and then you can configure that in Prometheus to scrape it. So what I've actually had running in the background is just that. So I've had Prometheus running the whole time, so it's been able to grab data. If we look directly at the containerd, I know it's really hard to see, but this is actually the raw output. So this is what a Prometheus endpoint looks like. This is the raw data coming from containerd. And then what you can do is I have it configured in Prometheus to scrape this. So if we look at the drop-down, you can see there's lots of information. So you can see all kinds of stuff about the CPU usage, throttling. You can see container memory information, such as if you reach kernel limits or out of memory OOM events. But let's take a look real quick at we just want to see total RSS or total resident memory bytes. So we just execute this. We can see, and we'll graph it. We can see quickly that it has it. It's been collecting these the whole time we've been running. And at the very bottom, if you look, you'll notice that these are actually, we use the labels that are the namespace. So you get the ID of the container, which is like Redis, which is in the default namespace, as well as the dev. So these will farm out all kinds of stuff. So you could split these out to say, all right, I want to deploy a new service. It gets deployed. We're going to deploy it to like the QA namespace, and all of a sudden the memory goes through the roof, right? You can easily and quickly see exactly what that does without adding any plumbing besides the Prometheus host and collector. So it's very, very powerful. Yes.
So it said scrape, so Prometheus basically scraping the wall and aggregating it.
Yeah, I'll go do a quick 30-second on Prometheus. We could probably have a whole talk on this, but the way Prometheus works by default is it goes and scrapes these. So this endpoint here actually there's no historical data. It just gives you a point in time snapshot. So containerd, if you look at these, one of them, for example, tells you the memory and the bytes. It'll just give an integer. Prometheus you tell it the interval that you want it to scrape, the targets. So I have it set as 15 seconds. Every 15 seconds, it's going to go to this endpoint. Whatever that value is, it then stores in the Prometheus store. So it maintains the long-term storage, so you don't have to worry about it at the target. It's kind of a different way of collecting metrics. A lot of times, you collect them local, and then you'll farm those up, but that adds a lot of overhead local. So this just provides this as, this is what I am at this point in time. You collect as often as you want.
Main reason I was asking was when you said scrape, it was one question I had is I see a lot of human readable text.
Yep.
Is there any way to like, tell these endpoints to embed JSON objects that can be precisely parsed rather than just trying to scrape?
Sure. With Containerd, you can't. It's Prometheus compatible. That's the Prometheus format that Prometheus expects. But you could write a plugin that does. You could use the metrics plugin to output it into any format you want. I don't think Prometheus does that by default. The Go library, I'm not sure. But that specific format, human readable, that's the way Prometheus expects it, and it's meant to be human readable so that if you hit it, you can parse it quickly. Yep. So now I'm going to go just real quick, and I'm coming close on time, to about the API client. So all of this, we were using the CTR command line tool. The CTR command line tool leverages the API client 100%. So it just scratches the surface with what it can do. If you actually look at the library, it is very extensive. Like I said, it's being used by Docker and Kubernetes. So all of the functionality you have there, you can do it through the API client. The Cry Containerd project by Kubernetes, which uses the Containerd for the runtime, leverages the API client, I believe. So I think they did that pull request a few months ago. So it's extremely powerful. It gives you a full client package, so it does all of the things that we showed plus more. It has services, so it does the same namespaces. It does distribution push and pull, so you can do push images. We didn't show here to do a push, but you can do that. Everything with containers, rootfs, the root file systems, you can do a lot of stuff there, as well as tasks, etc. So I'm not going to do a live demo, so you don't have to watch me type in code, but I've done this earlier, and so I just wanted to show, if you're not familiar with Go, you should be able to kind of keep along or keep up, but if not, it's not a big deal. So what we're doing here, walk through it. Basically what you do is you create a Containerd client, you just point it to the socket. That is the default socket that Containerd runs, and when you just do Containerd new, you have a client, right? From this client then, you can do, I'm going to basically walk through the example of what we did where we created Redis earlier. So now I'm going to create a context. The context in the Go realm is just basically a way to pass information back and forth, and gives you also ways to do like deadlines if you want to do timeouts around these things, specifically in the gRPC. So here I'm creating a dev namespace where I say namespaces with namespace, the original context, and here I'm naming it dev, as I did earlier. And then here we can pull the image. So we say we're going to define a variable Redis image equals client pull. So there I did CTR images pull. Same thing, only the first argument is the dev namespace that I want to do, and then the name or the reference that I want to use. So that could be anything, your GCR registry, registry on AWS, wherever you want. And then from that, you can create a container. Now this is hard to read, but client new container, the namespace you want to use, the ID that you want to have, and then the options that you want. So here, since it's an OCI, it's going to say with a new spec, which is the runtime spec, and then with an image config, use this, and then run from that image. And that's it. You have a container. So in like 20 lines of code, you could have your own Containerd service that actually pulls images and creates namespaces and executes and runs containers. So it's very, very powerful, the API. That's all I have. Thank you. The links here, Containerd, containerd.io is the site that gives you an overview, kind of a background, history. The org is there. As I mentioned, it is a CNCF project, so it's completely outside of Docker. We have a lot of contributors from Google, Microsoft, IBM, and more. And then the reference to the OCI if you're curious about the runtime spec or the image specs. So I think we have a few minutes for questions.
With Containerd, is the expectation you would then build your own version of, not maybe Kubernetes or OpenShift or some maybe platform as a service type business, then you could actually use Containerd to power those building blocks?
Yeah, and that's one of the reasons. Oh, sorry. The question is the intent or what you could do with Containerd is to build kind of your own platform, such as like Kubernetes or an orchestrator like that. And absolutely, that's what it's intended to do. Is I wouldn't say it's for the faint of heart. If you just want to use containers, use a platform, like for sure. If we've been doing containers for a long, long, long time, and I still get caught up on some of the things, like if you want to specify namespaces and what C groups you need to specify in those. But if you're a systems implementer on a platform like Kubernetes, or if some of the examples we have are large scale banks that look, we don't want to use Kubernetes, it's too much. We don't want to use Docker, it's not enough. So we're going to implement our own that does very specific targeted things, and we'll use Containerd as the base for that. So yeah, that's the intent.
Round of applause. Thank you very much.
Thanks for coming.